Hello all. Now today let's see the next topic, that is Bezier curve. In last topic we have seen the B-spline curve, and before that we have seen the approximation and the curve generation method. Now we will see the next topic, that is the Bezier curve. The question on this can be like, define a Bezier curve, state its properties, and you have to derive a function of Bezier curve, blending function. Another question can be like, you have to explain the curve, Bezier curve, with its properties. Likewise, so we'll start with the Bezier curve. It is again a different way of specifying the curve. Rather than same shapes can be represented by B-spline and Bezier curve, means it will be same like a B-spline curve. The same shapes are represented by using both Bezier curve as well as B-spline curve. What B-spline curve shows? It shows the smooth curves. So Bezier curve require the 4 sample points, and these points are completely specify the curve. So you can see in this diagram that it needs a 4 sample point, and the sample points are like A, B, C, D. What we have seen in Bezier curve, and before that in approximation we have a number of sample points and we try to pull that curve to pass through that sample point, right? Then in B-spline what we have seen, that rather than passing that curve to all the sample points, we have to pull that curve to pass through only from one sample point, at least one sample point. That is, we have seen it B-spline curve that will make the curve as a smooth, because whenever we are trying to pull a curve to pass through all sample point, at that time it forms some corners, and to avoid such a corners we are forcing to curve to pass through only one sample point rather than all the sample point, that we have seen in B-spline curve. Now in this Bezier curve what we are going to see, that we have to pass our curve by in given sample points. So this Bezier curve required a 4 sample point, and these are shown by A, B, C and D. So we will force our curve to pass through this sample point. So you can see the two types of that Bezier curve. This is also one type. The second type is the here are the 4 sample points A, B, C, D, and you try to pull that curve to pass through this sample point. So this is what the Bezier curve. Now how we are achieve this curve? So for that, the curve begin at the first sample point and 8 at the fourth sample point. You can see here the curve is starting at the first sample point, that is A, and it is ending at the last sample point, that is D. Here also the curve is starting with the A, ending at the point D. So this is what we have to do here. If we need another Bezier curve, then we have to again add the next 4 sample points. But if we want to draw a Bezier curve which are connected, okay, if we draw a Bezier curve which are connected, then in that case we can draw that curve by using a 6 sample points. How? If for one curve we require 4 sample points, if we want to draw again one curve, then we will require the 8 point, means 4 for first, 4 for second. But if that curve is connected, then it can be done in a 6 sample points. How? Then in that case the third and the fourth point of the first curve, third and fourth means C and D, the fourth and third sample point of the first curve should be made as a first and second point of the second curve. So you can consider this C and D as a first and second point of the next curve which is to be generated. So this is what the curve generation of Bezier. Now how the curve we have to draw by using some equations. So the equations we have seen for the approximation curve, there are equation, we are using a blending function over there. Again same for this B-spline curve, we are using a blending function for a single sample point. Now here also we are having the equation to follow to draw a Bezier curve, and the equation is like x is equal to x4 a cube plus 3x3 a square 1 minus a. Likewise, this is what the given equation, and you have to follow this equation to draw this curve. Here the value of a is moves from 0 to 1. The curve travels from the first to fourth sample point. But to construct a Bezier curve without this equation, whatever the equation is given, we can have another technique to draw the Bezier curve rather than using this equation. Now we'll see what is that different technique. So again I will say that we require the 4 sample points to draw a Bezier curve. The 4 sample points are A, B, C, D, that is given here. A, B, C, D are my 4 sample points. The point A, B, C, D are the original Bezier curve control point. This sample points we are saying as a curve control points. Mean by controlling these points we can draw the curve. So this is called as a control points. Here we are having the 3 lines. Which are the 3 lines? Initially AB, BC and CD. These are the 3 samples line to draw the curve. So here we have to find out the midpoint of this sample point. So what is the midpoint of the AB, BC and CD? The midpoint of AB is P. The midpoint of BC is BC is Q, and the midpoint of CD is R. So PQ are nothing but the midpoints of A, B, BC and CD respectively. After that we have to join these midpoints. So we are joining these midpoints like a PQ and QR. So what we have done, we have find the midpoint of these 3 lines and join that midpoint, and now it is forming a 2 lines, that is PQ and QR. Then again what we have to do, again we have to find out the midpoint of this newly generated lines, that is PQ and QR. So what are the midpoints? We are referring that midpoint of PQ as a S and midpoint of QR as a U. So again what we have done, we have finded the midpoint of newly generated line and mention it as a S and U. Then again what we are going to do, the same thing, that we are plotting a line to joining this midpoint. So line joining this midpoint is SU. So we have joined that line SU, and again I am finding a midpoint of this newly generated line and given as a name to that midpoint as a T. So now point T will be on a Bezier curve. So what is that point? That will be a third point. First point is A, the last point is D and the third point is T. That is a point on your Bezier curve. So this point T divides the curve into 2 sections. You can see the point T is dividing the curve, this curve, into the 2 sections. What are the sections? The first is A, P, S, T. The first section is this A, P, S and T. This is the first section of the given curve. What is the second section? Second is D, R, U, T. This is what the second section of Bezier curve. So these are nothing but the points, and you are trying to pull that curve to pass through this point. So for the first section it is passing from A and T, and for the second section it is passing from T and D. So this is what the drawing of Bezier curve. So by continuously taking the midpoints, we can find out the point on the curve and also split the curve into the 2 sections. We can continue to split that curve into the smaller section until we have the section too short that they cannot be replaced by any line, or they cannot be further divided till the size of section is not greater than the size of pixel. So you can see here the curve, the line SU are divided with the midpoint only single point T. No need to further divide that line. So we can stop here dividing and drawing the curve passing from that newly generated point T. So this is dividing the curve into the 2 sections. So this is what all about the Bezier curve. We have the equation, but we can draw this curve like by using a midpoint generation of the lines. So this is what the concept of Bezier curve. Now we'll see what is the properties of the Bezier curve. So properties are like we have to always passes that points to from given control points. So this curve always passes through the first and the last control points or the sample points. So this is the property that it should pass at least first and last sample point. If we follow the shape of the defining polygon, means whatever polygon we have defined, it should follow the shape of that defined polygon, and it is invariant to the affine transformation. Whatever the transformation we are having, scaling, rotation, then translation, shear, etc. transformations, that transformations are invariant for this curve. Now we'll see the difference between the Bezier curve and the B-spline curve. So what we have seen in both the curve, the first difference is any shape of the curve is achieved by the Bezier curve. We have seen that B-spline curves are used to draw a smooth shapes or a smooth curves. So Bezier curve, by using that you can draw a smooth also and you can draw a rough curve also. Then on the sequence of control points, the shape of the curves get changed. We have to follow the sequence, that means first and the last point the curve should pass through that sample points. So here the sequence matters for the changing the shape of the curve. Here the shape of the curve is not changing by the change of sequence in B-spline. Again in Bezier, by passing the curve from the sample points we can get a sharp corner. If we force the curve to pass through all the points, then it may form the sharp corners, means like this. If we are forcing the curve to pass through this sample points, then it will create a sharp corners. Then we can achieve that in the B-spline curve by using sharp corners by using the blending function repeatedly for the same point. So if we are applying the blending function again and again, then the curve will pass through the all sample points and it may generate the sharp corner in that case. Then the last difference between this, the Bezier curve is always passing from the minimum 2 points that we have seen, that is first and the last point are the minimum passing points for that curve. In the B-spline curve we try to pass the curve to only a single point, but in some special cases it may happen that the point is not passing from any of the sample points. So this is what the difference between the Bezier curve and the B-spline curves. B-spline works on the blending function, whereas Bezier works on the control points. We have the equation for Bezier curve also, but by finding the midpoint we can find out the Bezier curve over here. So this is what the difference between this Bezier curve and B-spline curve. What are the advantages of that B-spline curve over the Bezier curve? That B-spline compute faster than the Bezier curve. Okay, because here we are finding the midpoints and then joining that midpoints and again finding the midpoint, again we get a single pixel. Then they are a smoother and easier to control, means B-splines are used for smooth curves, so they are smoother and easier to control. Again the control point gives the better idea of the shape of the curve. So if we have the maximum sample points, then curve will be more smooth. That was the concept behind the B-spline curves. So these are nothing but the advantages of the B-spline or your Bezier curve. So here we are finishing the topic, that is Bezier curve generation. Thank you.